Hello, everyone, and welcome to today's webinar on how to simplify your project plans. I am so excited to introduce today's webinar. My name is Liliana Stefan, and I have been with Realization for the last 10 years. For those who are not familiar with Realization, here is a brief description. Realization was founded in 1998, and we have been at the leading edge of innovation in project management ever since. We were the first to introduce web-based project management, first to introduce multi-project management software, and first to embed critical chain project management methods in our software, and the list goes on. What we are proud of is the bottom line results of our customers, such as Boeing, Delta, the US Navy, and the US Air Force, Medtronic, Siemens, and others have achieved. By finishing more projects faster, in the last 17 years, our more than 300 customers have realized over $5 billion in hard savings. Our company and our clients have won many industry awards, including the France Edelman Award, Shingo Gold, and the U.S. Air Force Chief of Staff Excellence Award. What we will cover today is our next simple but powerful innovation in the area of project planning. Before introducing our speaker, I'd like to go over a few items. A recorded version of today's webinar will be sent to you later, just in case you need to refer back to any of the slides or you'd like to share it with your team. The webinar slides are available for download from the Handouts tab on your GoToWebinar control panel. You can ask questions at any time during the webinar. Just use the Q&A section in the control panel. We will answer all your questions. If we run out of time, we'll answer them later after the webinar has ended. We will have a few polling questions, which we are encouraging you to respond to. Now, I would like to introduce today's presenter, Sanjeev Gupta. Sanjeev is the founder and CEO of Realization.
Hello everyone. And so we will try to keep on time, and the flow of the presentation is I will just recap the background very quickly to describe the problem we are solving. Then I will get into the how of we solve this problem. And this how is comprised of three parts. One is the basic concept. Second is examples of how this concept is applied for different types of projects. And third is some guidelines for practically applying these concepts. In terms of the solution that we will discuss today, just a very quick thing that it's a very simple and almost an obvious solution. So it will not be something that is really rocket science or something very complex or something very advanced. Actually, the beauty of what we will present to you today is something that is very simple. So with that, we will get started. We all know that in terms of the background, the project plans, we create project plans, especially when we are managing large projects that involve multiple organizations, multiple enterprises, or multiple departments or multiple teams. And one of the functions of the project plan is synchronizing all these different participants as the project is being executed. And the second part is, of course, the control. And the information that comes out of a project plan is you get information about the resource plans, you get information about the inputs that you need so that you can plan those inputs to arrive on time. You get critical path information about the project so that you can understand how long the project will take and how to shorten the project timelines. Using the critical path information, you also get project status in execution. And again, using the same critical path information, you also can derive what are the daily priorities by looking at which tasks are most critical that need to be done first, and so on. Now, the core data in a project plan, we all know, is these few data elements. You have tasks, You have durations, you have resources that are required to do those tasks, you have dependency between the tasks, and then you have some dates, milestone dates or project end dates, as well as the input dates. The challenge, of course, is that in projects, everything is in constant flux. So you can create a very nice project plan on the front end, but almost as soon as the plan has been created, you start experiencing these changes. You have scope changes, which means the entire structure of the project can change. You might have new tasks that need to be done. So the scope remains the same, but you have new tasks that need to be done to accomplish the scope. You might have changes in the sequence, in the sense that if you are doing, for example, some product development project and you need to do some analysis and studies, you might start out thinking that the analysis and studies needs to be done in a certain sequence, but then you change the sequence as you get into execution and you encounter some technical difficulties. The task might take longer than expected, the resource requirements change, inputs are delayed, and there's rework. And the impact of all these changes is that all the data elements that comprise a project plan, they keep changing. They're in constant flux. And the implication is that the plans keep changing, and we make the problem becomes worse when you have very detailed project plans. With the advent of computers and computer-aided project planning software and project tracking software, one trap that we have fallen into is capturing a lot of details about the project into the project plan. And the combination of those two things, what it means is that the plans are so detailed that even if the plans are not changing, the only people who understand those project plans are the project planners. And because the changes are constant in terms of the task durations, the dependencies, the sequence in which tasks are being executed, the critical path is changing all the time. So it's okay in a project if the critical path moves from one path to another. But if the critical path keeps oscillating between something is not critical path today, something else is on the critical path tomorrow, then the thing that was on the critical path today again came on the critical path. So that fluctuation, that constant change is what is bad. So it's absolutely acceptable in a project that the critical path can change over the duration of the project. But if it keeps oscillating back and forth, that is what makes it unreliable. And as I described in the beginning, when you're trying to understand the status of the project, or when you're trying to understand what your daily priorities are, they are all coming from this basic critical path information. And if the critical path is volatile and is unstable, then the information that is coming out of the project plan is pretty much useless. And on the execution side, you create a very detailed plan hoping that it is going to help people in execution. But in reality, what you find is that the only people who use the project plans are the project planners. Everyone else has to be forced to use and update the plans. One of the symptoms that we have seen is creation of artificial metrics like daily update compliance, where people really don't want to update the plans, but they are forced to update the plans by creating these artificial metrics. And as far as managers are concerned, whether it is the project manager who's looking at the overall project or is a task manager who's looking at a set of tasks within a project, what we find is they create their own back pocket project plans. So the formal project plan is inside some formal system, but what they are using to manage the project at their level is a back pocket project plan that they refer to, whether it is a project manager who's looking at the overall project or the task managers who are looking at the details of their own tasks. And because the actual project, the formal project plans are not being looked at or not being updated properly, or they're constantly changing, what we also find is that for daily work schedule management and for control, it's pretty much ad hoc, because you look at your own version of the plan and based on that you decide what priorities should be followed or you follow priorities based on whoever is shouting the loudest, rather than referring back to the formal project plan and deriving your priorities from there. And finally, what it all means is that the formal project management systems, they fall into disuse. So when we introduced critical chain method into our software, we did solve these problems somewhat, but not fully. So we did extend the life of formal project management systems. We did extend the usefulness of project plans. But even in our best implementations, what we find is that in about 3, 4, 5 years, the symptoms start showing up where people have to be forced to use the project management system and project plans. And normally they are just going back to their old methods of using their own local priorities rather than the project plan. So this is the problem that we have grappled with, that we are trying to solve, and that is what we will share with you today. I'm not going to read through this slide. This is just for you to look at and kind of just see that, in our opinion, what are the characteristics of a good project plan. So first of all, it should be user-friendly. Secondly, it should provide stable and reliable information. And third is it should support synchronized execution. And then there are sub-bullets that you can read on the screen, which are pretty obvious, so I will not go through those sub-bullets. What I instead want to do is get into what is the change required in our thinking about a project plan that will allow us to actually create good project plans. And the change in our mind is very simple, that the trap that we have to get out of is that instead of treating the project plan as a detailed schedule, we have to just treat it as a master plan, only a master plan. So what I mean by that is that it's a project plan is good for key milestone dates or external commitments, but it is not good for start and end dates for every activity that happens inside the project. Similarly, the project plan is good for managing dependencies between departments and teams, but the project plan is not a detailed sequence in which activities should be performed. Similarly, the project plan is good for overall resource requirements in terms of how many people or what skill do I need in which week, but it is not good for managing people's detailed schedules. And similarly, as far as the inputs are concerned, so the trap that you can again fall into is you can say that since we have a detailed project plan, we can manage the inputs on a just-in-time basis, but reality is that just-in-time is just a mirage, because sometimes when you need those inputs can change, and sometimes the inputs themselves are delayed. So instead of trying to manage every input on a just-in-time basis, what you should be doing is you should be managing some certain full kitting points for these inputs, and the project plan is good for managing those full kit points, not the detailed schedule of every input. And if we accept this change, the need for details does not go away. All we are saying is that from a planning perspective, the plan is just a master plan. Yes, you can capture all those details as long as the intention of those details is not to have a detailed schedule. I mean, the solution that we are proposing is actually quite straightforward and simple, which is that the project plan should be a two-tier project plan, which means there is a set of tasks at the top, and beneath each task are subtasks and checklists. This tier one, which is comprised of the tasks, is the tier that is used for project management, which means tier one dependencies are what determine the critical path. This tier one plan does not need daily updates, and it should be relatively stable because we have minimized the number of tasks. Tier two is where you can capture a lot of detailed sequences if you want to. You can even capture people's names in terms of who exactly will work on these subtasks and checklists. So you can capture a lot of details over there, but these details are not flowing into the schedules. So these details are for local reference only, and They are very flexible, very dynamic, but the information from these detailed subtasks is not flowing into the critical path of the project. So what we are saying is that there might be these tier 2 subtasks and checklists, but these subtasks and checklists are contained within a task. You do not have dependencies between subtasks that belong to different tasks. So dependencies at subtask level do not flow across the tier 1 tasks. And this is an important point, because in a lot of planning methods, you can have level 1, level 2, level 3, level 4 planning, but the subtle change that we are saying is that the dependencies exist only at level 1. The dependencies that determine the critical path. Any dependencies that are at the lower level do not flow across the tasks. They are contained within the tasks, and they are not, those dependencies are not used for any kind of scheduling or critical path management. The second use of this tiers is that based on the critical path, you can determine what is the priority for tier 1 tasks, and that priority information can flow automatically from the task to the subtasks. But the status updates do not flow automatically from tier 2 to tier 1. So what we mean by that is that a task manager or an IPT lead or a supervisor who's managing the details inside a task, they can manage all those details using subtasks and checklists. They can even keep track of how long is the subtask taking, or how many subtasks got done on a specific day. But as far as updating the remaining duration for the tier 1 task is concerned, that is something that they have to do it manually. So level 2 information, tier 2 information is there for reference, but it does not flow automatically into updates of remaining durations for tier 1 tasks. And this is kind of the straightforward, simple solution. And to illustrate the solution, what I want to do is quickly show you 3 examples. First, we'll pick a very simple project, which is an engineer to order environment, which is one of the simplest project environments you can have, where you take a standard product, you make some modifications to the different modules of the product, and you are done. The second example we will pick up is aircraft maintenance and repair and overhaul, which is more complex than engineer to order, but not still very complex. And the final example we will pick up is from a new product development of a complex system like a satellite. So let's just show you now these 3 examples. And I'm just changing over to the software now. Okay, so this is the engineer to order example. So what you will see here is a project that is about 6 months long. And if I look at the number of people working on this project has about, so this is a real life project that we took. So this project has about 20 engineers working over 6 months on different details inside the project. And originally, before we implemented critical chain over there, they were trying to manage this project using about 400 tasks. When we implemented critical chain, we brought the number of tasks down to about 75. But with this 2-tier concept, now this project plan can be simplified into about 3 times 6, about 18 tasks. So, and the tasks are very simple, because across the top, what you see is the actual flow, which is you have an initial package, then you do some reviews, final package, and so on. And on the left-hand side, you have the different modules, both hardware and installations in this case. And below these modules, you will have detailed parts. So you have these tasks in the initial package for bushings, for example. So you have aluminum bushings, nickel bushings, bronze bushings, and so on. So you have a list of all the bushings that need to be done, but all these bushings don't need to be separate tasks inside the project plan. And they don't need to be done in a specific order. They can be done in whatever order the task manager thinks that they can execute in given the resources that are available to them on a given day. So they can still manage all the details in terms of how do they think each of these when they hear in terms of how long these tasks will take, the software can calculate, for example, what is the impact on the overall task duration, but we don't take that information automatically into the remaining duration update of the higher level task. So this is one example of how we have collapsed the details and contained them locally inside a task. Another example I want to show you here is the full kitting. So instead of managing multiple lists, multiple inputs that integrate or feed into different points in the project plan, we are aggregating all those inputs into this one full kit point. What we are saying is don't start the first phase until all these inputs are there, at least from a planning perspective. And so in planning, your effort should be to get all these inputs on the front end of the project. In reality, some inputs will be late, so they might arrive when you actually execute the project. But from a planning perspective and a representation perspective, you need to just manage these inputs coming into one single point. Let me now also show you a timeline view of the same project. So again, the timeline view is pretty straightforward. For those of you who are familiar with critical chain, the red boxes represent the critical chain. For those of you who are not familiar with critical chain, think of that as the critical path of the project. The important point I want to highlight here is you can see why this critical path is going to be very stable, right? Because at the most, what can change is the durations. A lot of these dependencies will not change. All the dependency changes that will happen will be at the subtask level or at the checklist level. And so therefore, this critical path is not going to fluctuate and keep oscillating from one critical path to the next critical path. This critical path is going to remain relatively stable. What it means for the project manager is that the project status that they get today will be approximately the same as the project status that they will get 2 days from now. Instead of feeling that my project is on time today and suddenly is out of schedule, behind schedule, and then it's suddenly on time, or not knowing where to focus to expedite the project. So this is an example of a very simple project. Now let's take a more complex example, which is aircraft maintenance, repair, and overhaul. And to give you the background about this project, so this project is about 6 months long also, 200 days. This is a 200-day project. And in maintenance and repair and overhaul, what they have is for every repair that they do or every piece of work they perform, they have something called a work card. So there are 700 work cards that are inside this project plan, representing about 200 days of duration and give or take about 70 to 100 people working on the project through its life. When we originally implemented critical chain, before we did that, actually the project plan was these 700 tasks, which was totally unmanageable. When we implemented critical chain the first time around, we reduced this number of tasks to about 75 again, which was a massive simplification. But even then, what we found was not really a user-friendly project plan, and even that was pretty unstable. Now with this two-tier concept, we have collapsed this project plan into about 15 tasks. And again, let's look at an example of what is a task versus what is a subtask. So let me drill down into, so there's a repair and installation of the interior and testing of the interior, right? So what you have is a very detailed list of all the things that need to be done inside the interior in terms of repair and installation. And the sequence again in which these individual repairs or work cards would be done is quite flexible. They can be done almost in any sequence. And sometimes the sequences are determined by what is happening on the rest of the project, or where do you find space, or where are the mechanics exactly, which mechanics are exactly available. And those details can be managed by the supervisor, not by the project manager, but by the supervisor of this task. And the critical path of the project is not affected by those day-to-day scheduling decisions. So let's go back to the high-level project plan from the subtask. Right? And in this project plan, again, what we have determined, what we have established are two full kit points. So one is a full kit before the first task starts, which means all the approvals that you need, all the engineering changes that you need based on the repair that you knew before you started the actual work on the aircraft. All those things are available before you actually start work on the first task. And then the second full kit point you see is where you are beginning to install all the parts back into the aircraft. So the process is that you prepare the aircraft, you do the disassembly, then you repair the different parts, and then you start installing them back. So before you start the reinstallation process, there is again a full kit point. And again, the point is that this project plan is much more simple. Let's see the timeline view. What does the timeline view of this project looks like? So again, what you will see is the critical path is comprised of only 5 tasks. And by definition, this critical path is going to be very stable. And because this critical path is stable, the priorities that you're going to get on a day-to-day basis are going to be stable. And stable priorities, by the way, are important if you want to reduce the amount of multitasking in your organization. If your critical path is changing every day, it means the task priorities are changing every day, and it means you are actually forcing people to multitask. But if you can hold the critical path stable, that means you can hold the priorities stable, and that means you can allow people to focus and finish what they're working on. Now let's take a final example of a product development project. This is slightly more complex. It's not as linear a structure. In this project plan, for simplification purposes, we have just illustrated 2 phases. There is front-end analysis and design of long lead items, and then there is the design of the rest of the items. And again, this is a very complex project, multidisciplinary project. A team of about, I think on the front end, about 40 engineers work on the front end on this project. And when you get to the detailed design, there are actually about 200 engineers working on the project. And we have taken all that complexity and reduced it to about 30 tasks by following this 2-tier structure. And again, let's again look at one of the examples of task versus subtask. And so what you can see again is that all these activities that are inside a task, they have to be performed, and those details are necessary for the IPT lead, who is the task manager in this case, for them to know what is all the detail that needs to be done. But that is a detail that is relevant only for the IPT lead. It's not relevant for the project. How those details get managed, in what sequence those activities get done, the project manager does not care. Rest of the organization does not care. That is a very local detail for the IPT lead to manage. And they can manage it without encumbering or affecting the critical path of the project. And I think, so again, let's look at the timeline view here. Right. Again, what you see is the critical path, which is the red tasks, is 6 tasks. And by definition, again, this project plan is going to be much more stable. This critical path is going to be much more stable. And one more advantage you get out of all this is that when you reduce the number of tasks, now you actually have a visual project plan that you can hang on your wall, and everyone can look at it and really understand what is going on inside a project. So this is what I wanted to show you in terms of the examples of how we have applied these concepts. Now let me go back to, and all these examples we have captured in the slides here that we will send to you after the webinar. Now, the final part of the how in terms of when we define a task. So the trick here is determining what is a task versus what is a subtask. And here are some guidelines and a recommended process for doing that. So guidelines are that task is a chunk of work that should ideally be done in tandem or without interruptions. So if you have a lot of activities that need to be done, yes, they are separate activities, but ideally we want to get all these activities done together because they are done by the same team, or they need to be done in tandem because there is multidisciplinary teams involved and they need to constantly share information. So I'll give you an example of that. In satellite product development, you have analysis that is related to the temperatures or the thermal analysis. There's analysis regarding space. There's analysis regarding reflectivity. All those analyses that when they're happening on the front end, they are being done by specialists from different departments. But the analysis that happens in one department affects what happens in what decisions are made in the other department, which means all these different analyses need to be done in tandem. So instead of declaring them as separate tasks in a project plan, what we are recommending is that they are just subtasks inside one larger task. And when you do that, what you do is you automatically force these activities to happen in a synchronized way. And again, the more than one type of resource can work on the same task. So a task is not something that is done by an individual or even a skill set. Sometimes multiple skill sets can be on the same task. And the other practical guideline is that typically the task should be between 1 to 4 weeks. Now, sometimes they can be more than 4 weeks, sometimes they can be less than 1 week, but a majority of them should fall into 1 to 4 weeks duration. And the process that we recommend is that instead of starting bottoms up, start top down, which means start at the phase level, because any project, if you look at it, everyone knows what the phases in the project are. And for each of these phases, what you do is you define meaningful deliverables on the left-hand side that we saw, which we are calling the scope items. And you pick up each scope item and define the major steps that are required to produce those deliverables. And then inside those tasks, you can list the detailed activities, and you can aggregate all the inputs that are coming into the project plan into one kit list, one full kitting list, right? So for example, to make it more concrete, in the project plan that we did for the engineer to order, we know the phases are you design, then you procure, you do some assembly, you do some testing, and there's an assembly design that is going on. So these are the major phases, if you will, that happen inside the project. So we know those phases. Then we define what are the scope items that need to be done, what are the different modules that need to be designed, and what are the different modules that need to be procured, and what are the different sub-assemblies that need to be created, and what are the different tests that need to be performed. And we define what are the steps that each of these phases goes through. So that helps you define what is a task, what is a subtask very easily, starting top down from phase, going down from phase to scope, to deliverables, to tasks, and then to subtasks. And similarly, on the input side, instead of managing all these inputs that can come at various times in the project, you try to club all these inputs into one full kitting point. So again, as I said in the beginning, the concept is very simple in terms of what we are recommending. All we are saying is, yes, you can capture all the details that you want inside a project plan, but do not capture those details to manage schedules. You can capture those details to help out the local team leads, but the information that is flowing into the critical path of the project, that level of plan, which is the tier 1 plan, should be very simple. And with that, I'm ready to take questions if you have any. So the first question I have here is, how many organizations have we implemented this concept in? So out of about 300 or so clients that we have, so every new implementation we are doing, we are implementing this concept of two-tier planning. And amongst our existing customers, I think we have about 20 or so customers who have, where we have gone back and re-engineered their project plans according to this two-tier thinking. So that was one question. Any other questions? Okay, the question is, in what types of environments has this concept been more useful? Or are there some environments, I think I'm interpreting this question to mean that are there some environments where this concept is better, more suited than the other ones? So this is, I think we have found this concept to be universally useful, but for slightly different reasons. So I'll try to illustrate it. In India, for example, we are managing very large infrastructure and construction projects that have thousands of people sometimes working on the project at a given time. And over there, once you get into execution, the process is very predictable in terms of, you're going to pour concrete, then you're going to do build a wall or whatever you're going to do, right? So, but over there, the main value that is coming out of the two-tier concept is that we are able to capture a lot of detail inside the project plan, but not make the project plan look very complex. And the second value that we get is that in these large infrastructure projects, while the process is predictable, the resources that come to the site, the labor that comes to the site, you plan for 500 people to show up. In reality, only 300 people might show up. So by keeping that detail out of the project plan in terms of exactly which task will be worked on which date, we reduce the volatility at the higher level project plan. So this is an example of an infrastructure project. On the other extreme is product development projects where there's a lot of volatility in terms of scope, in terms of technical requirements, in terms of the sequence. So again, the value that we get out there is that you are able to manage all that volatility without making the project plan volatile. So the quick answer is that this concept of two-tier planning works in many environments. Maybe the benefits are slightly different in each environment, but it does work. We have implemented this in complex IT projects and software development projects. We have implemented this in complex engineering projects. We have implemented this in construction projects, and we have not faced any specific obstacles or issues in trying to implement the concept based on the environment. I think those are the two questions. I don't see any other questions on my screen. So with that, I want to thank you for attending this webinar. And now I will hand it over back to Liliana, and we'll take it from there.
Thank you, Sanjeev. We do have a few more minutes, and I see a few more questions in the question panel. One of them is, I do have to scroll. The subtasks we saw all had a one-day duration. Was this an actual estimate or just
I see that,
to act as a checklist?
Yep. That's a very good question. So no, so those were just, this was not an actual estimate. This is something we just did not update, but some of those subtasks actually have durations that are longer than 1 day. Sometimes those subtasks can have durations of 3 days, 5 days, etc.
And then another question was, what software were you using?
Okay, so the software we are using, so I don't want to focus on the software part as much in today's webinar, but the software that we are using is a special planning module that we have created inside our own software, which is Concerto. So we have created this two-tier planning module And we were forced to create it because we tried to use Microsoft Project to do two-tier planning, and it doesn't work over there. Yes, you can have summary tasks and different levels of tasks, but you cannot contain dependencies properly inside within a task in Microsoft Project. So we had to create our own software to implement this concept.
Okay.
Yep. And one more question that I see is that my projects are 4 years in duration, and I need status of detailed tasks to manage cost. So I think this is a bigger discussion than what we are intending in this webinar today, because you are also raising the question of managing cost, which is a whole different webinar. But the simplest answer that I can provide is that the detailed task status is still available. All those subtasks and checklists, you can do whatever you want with that data in terms of collecting the data, compiling the data, slicing and dicing the data. The main point we are saying is don't use that data to manage the critical path of the project.
I think we have time for another question.
Sure.
Which one do you want to take?
Yeah.
We have one.
Yeah, go ahead, Liliana.
For an organization that has been scheduling traditional detailed plans for a while, how do you approach the IPT leads to think in this new way? What kinds of questions do you ask to change their paradigm to think from top down?
Yeah. That's very good. So I don't know if there is a standard answer we have found there in terms of getting the IPT leads or the task managers to think like this. And what I mean by that is a lot of times these people are very happy that we are taking down the level of detail from the project plan that they have to report against on a daily basis and not really use the project plan. So we have seen the reaction where IPT leads are actually very happy, and this really appeals to them because they do want the details, but they want to manage the details locally. But on the other side, we have also seen situations where the IPT leads insist, or the task managers insist, that you have a lot of dependencies between subtasks that flow across the project, across the tasks. And then we have to sit down with them and discuss with them, how a lot of that is just noise that does not need to be managed, affecting the critical path of the project. So I don't think I have a standard answer in terms of how do we get the buy-in. Sometimes the concept just appeals to people, and sometimes they have a lot of obstacles in their mind that we have to work through. And one more question was, can we export information from the planning tool into other programs like Excel? Yes, we can. So, again, it's a tool question. The focus today, I wanted it to be on the concept. And one question which is kind of out of scope again, but is about earned value management. Is critical chain compatible with stringent earned value rules? Again, I think that is a very, there's a question on which we can spend another full webinar on which we can do that. So I won't be able to answer that question satisfactorily today. But the simplest answer I can give you is that earned value is compatible with critical chain or this higher level of cost management. So it is very compatible. But you need to work at it in terms of you need to work out the details, because you have sometimes customers who want certain things from the earned value reports, who have certain standards in terms of earned value reporting. So it's a matter of just sitting down and understanding what those details are, and making the two compatible. Otherwise, we really don't see an obstacle there. Okay.
Thank you, Sanjeev. Thank you for all for the presentation. Now, if we do hope that you'll be taking those principles that we presented today and apply them to your daily work. If you'd like to implement any of these two-tier project planning principles, we invite you to set up a call with us, or we'll be more than happy to do a site workshop for you. Thank you very much. Thank you, Sanjeev, and thank you to everyone for attending today's webinar. If you have any other questions, please feel free to contact me at the email address listed on the last slide of the presentation. You will receive a follow-up email within the next day or so with a link to view a recording of today's webinar. On behalf of Realization, thank you for joining us today and have a great rest of your day.